Okay. So we're gonna start by talking about um, quiz 2A, which was the quiz for today. So let's get started. So this graph. So the idea was you look at this graph. Let's turn off the ruler. Um, so the idea was to look at this graph and pick off the values here. So let's see. Yes, that was a Jimmy Buffett reference for the title. And the WebAssign was there was a extra credit that was due on Friday, which was about functions. If you didn't get to it, go ahead. You can request an extension right off the thing, an automatic extension, and it will let you do it. Okay. So basically, what this thing asks you to do is it's got, of course, a visualization, a graph, and it's asking you for the various values. So if I head off to negative infinity, I go to 0. And then the limit as I go to negative 2. Well, if I go to negative 2 from the left, I hit 2. And if I'm going from the right, I hit 2. Okay? So how do we feel about those? So this is question 1. Parts A and B. How do we feel about... Oops. How do we feel about those 1 to 5? Right, I don't have to reach this value. It's just where I'm heading. And here I'm heading to, as x goes to negative infinity, y goes to 0. Okay. All right. Now this one is 6. As x goes to 0. So one of the things about limits, right? I can reach the point. But I don't need to. All right. So here I've reached the point. Here I actually reached the point. Um, here I reached the point. Here I didn't. Oops, you can't see that because I'm using the wrong mouse. Here I reached the point. Here I didn't. And then f of 3 is just 6 because if I go to f of 3, if I look at this graph, this nice little piecewise graph, it's just 6. So how do we feel there about C and D, 1 to 5? All right. And if you find this confusing, by all means, come talk to me about it. Let's go over it. Go talk to the tutors. And everyone saw the thing where you got online tutoring through the ASC, right? So the Academic Success Center. So there's free tutoring there, and you can come see me during office hours. And I will be happy to go over it with you, and we can talk about it. You can talk about it with the tutors. These are things that are really in their wheelhouse, and they'll really be able to help you with these things. Um, Now G is D and E. We'll get to that. E and F here, 4 and 2. So as I go to 3 from the left, I get 4. As I go to 3 from the right, I get 2. How do we feel about that one, 1 to 5? So that's E and F. E and F there, 1 to 5. All right. Well, 4 does not equal 2, at least not this week. And that's why that one of for part G does not work. So right, the derivative, the limit from the left is not equal to the limit from the right. Therefore, there's no two-sided limit. Okay. And that's Gracie again. I know this is what you really want, so you know, the Gracie cam. She's sitting in there in the green screen, making it all messy. Okay, and then for the last one, so I've got a couple questions. For G, put D and E. Yeah, f of x. It's not really f of x. It's like f of anything in between is like -1. It's not quite -1, 1. It's like 1 to 3. Um, yeah, for part G, if you put the left hand and the right hand limit are not the same, um, yes, that would be correct. It would need to be for the limit to exist. That is correct. Um, okay. All right, and then this last one. The problem with this last one is that it never settles. So it doesn't. It kind of. There was one in there about the image being between -1 and 1 always. That's not quite true. And this one would be between 1 and 3, but you kind of have the idea. But this function just never settles. Um, so how do we feel about that? 1 to 5. Oops. So this is part H. How do we feel about that one? 1 to 5. All right. A is 0. That's a good question. So someone's asked why is A 0? Let me kill the poll here. So A is 0 because here, as I go off to negative infinity, I'm getting closer and closer and closer and closer and closer and closer to 0. So that's like that. So if I pull up the function 1 over x, right, and everybody should kind of have the idea of what this looks like kind of in their head. Let me close some of these windows here. So 1 over x is one of those things that you should just kind of have in the back of your head, right? As I go off to infinity, right, I get closer and closer to 0. I don't quite hit it, right? I never get to 0. But for any arbitrary distance away from 0, I'll get there eventually, right? If I give you if my arbitrary distance is 0.01, if I run this thing out to 100, there I am under 0.01. Right? So for any arbitrary y distance away I want, I can get for any arbitrary distance away from 0, right? For any little arbitrary there we go. For any little arbitrary distance away from 0, there comes a time, there comes an alpha, there comes a value, whereas I'm always that close to 0. All right? I'm always closer to 0 than that arbitrary distance, right? If my arbitrary distance was 0.1, then there is a time, 100, where I'm always closer to 0 than 0 plus 0.01. Okay. So that's this idea is I can get arbitrarily close in this other thing. Does that help explain what you were after? Okay. Perfect. Right. So here this side never settles. So let's look at another function. Let's look at sine of x. So if we look at sine of x, here's sine of x, right? Sine of x never settles. There's no getting smaller and smaller, whereas sine of x over x does settle, right? It moves away, but every time it moves away, when it returns even closer, right? The maximum distance away from 0 gets smaller and smaller and smaller as I move to the right. And for any arbitrary distance away, I could eventually get it to be, I could eventually get on inside there. And now there's a question. So remember, we're now in week 2. We're now in half credit retake. So you can make up half the points you missed. Okay, so that's that idea that this kind of settles eventually, right? I mean, for any distance away, I can get there. But this thing doesn't, right? If I take away this x, this thing doesn't settle. It just goes forever. So there's not really, if I say 0.5, well, there's always a time when I get outside 0.5. But in the other case, there wasn't. Does that make sense? Is that a little bit clearer? Yeah. Okay, G. In part G, the limit from the left doesn't equal the limit from the right. So let's put this back on here. Do you see here in part G how as I come from the left, I'm heading to 4? But as I come from the right, I'm heading to 2? So these two limits are not the same. I'm not heading to the same place, right? This thing's heading for Atlanta, and this one's heading for Jacksonville, and they're just not the same place. Yes? The limit from the left is heading for Atlanta. The limit from the right is heading to Jacksonville. It's not the same place. Right? And here's Raleigh, just up here, but I don't care about Raleigh. Well, they have to head to the same place. The limits have to be equal. Not the function. The limits have to be equal. So here, you can see in part B that the limits are equal. I'm going to the same place from the left as I am from the right. And up here, it's the same thing. I'm going to 6 from the left as x goes to 0. And here I'm going to 6 from the right as x goes to 0. Yes or no? I mean, if it's a no, that's okay. We just need to move on, and I'll talk to you about it later. Because we'll play with this, because that's an important thing. Okay. All right. So let's move on a little bit, and I'll be happy to come back to this and talk to you about it later. Let's move on to the next one. So what I want to do is I want to graph a single function that meet all of these conditions. Let me erase it and show you what I did as kind of a thought process. So my thought process is this. What I'm going to do is I'm going to treat infinity as a number. Okay? It's not really a real number. I mean, it is a number. But I'm going to treat it like it is. So this is the x. As x goes to infinity, y goes to 2. I'm sorry, negative infinity. So I'm going to actually put negative infinity 2 on the graph as a point. So I'm going to come up here. I'm going to do negative infinity 2. Oops, I'm going to do it in purple. And then I'm going to move on. I'm going to leave that point there. And now I'm going to do negative 2 infinity. And notice that this is a two-sided one. Okay? So I'm going to put negative 2 left on the thing, infinity, and negative 2 right. And I'm just treating them like points. Now, positive infinity, negative 4. Positive infinity in the x space is way over here. Right? There it is in the x space. And negative 4 in the y space is down here. I'm going to put an arrow right there. Okay. One right 5. So what I'm going to do is I'm going to come over here. I'm going to go to 1, 5. I'm going to draw an open circle, and I'm going to give it a right tail. One left, negative 4. I'm going to do the exact same thing. And then 1, 3. Okay. How do we feel about this idea that I'm drawing the points on the thing before I even, I'm just treating these infinities like points, and I'm just putting them up there. How do we feel about that, 1 to 5? Right, and notice I'm not messing with any of the stuff in the middle. I'm just doing the bare minimum of the stuff that's listed. All right, now that I've got all my conditions in the middle, I'm going to leave G for now because it's a weird defined everywhere condition. Oh, did it reset the poll? That's annoying. Okay. I'm not sure what it did. Yeah, so when you do retakes for half credit, yes, you will do it in Proctorio. Okay. Now what I'm going to do is I'm going to just connect the dots, okay? So what I'm going to do here is just connect the dots. And I'm going to do it from left to right in a way that doesn't violate my vertical line test. All right. Maybe a little pencil action would work better here. So let's see. I've got this point here, way down here, and I've got this point way up here. And that's going to be kind of an annoying thing to connect, but I'm going to do it. I don't have to. I can actually cheat this a little bit by doing another jump, but I'm not. And here I'm violating my vertical line test, so I'm just going to erase that little bit there. There we go. And here, again, this is isolated. This is my next little jump. So I'm just going to come down. Going to come up this way. And connect the dots. And then maybe I'll give a little notation for the grader to see where my asymptotes are. So let's just do that. Let's see. I've got one here. Oops. See, I have another one here. And I have another one here. All right. And then I'm going to go back and check my conditions. Well, is negative infinity 2 on this graph? Yes, it is. So check. Is negative 2 left infinity and negative 2 right infinity both on that graph? Yes. Is positive infinity negative 4 on that graph? Yes. Is it the case that as I go to 1 from the right, I go to 5 in the y? Yes. Is it the case that as I go to 1 from the left, I go to negative 4 in the y? Yes. Is it true that f of 1 equals 3? Yes. Is f defined everywhere except maybe x equals 2? Yes. Well, let me do a little touch up there to make sure that the grader doesn't ding me for that. All right, and have I violated my vertical line test? No. Okay. So this is good. I could put a point on here if I wanted to. I don't have to. So do you have to write all the asymptotes? No. That's just helpful for the grader. That's just, I meant to put an asymptote here. So if the person's not quite sure about what you mean to draw and you drew the little dotted lines, the person's now sure about what you meant to draw. If you're having troubles with graphs, and if you're having troubles especially with graphs in general, please go see the tutors or come see me. We need to talk about graphs. If you're having trouble plotting points, come see me. We'll talk about it. I'll be happy to talk about it with you. I'll be happy to go over it with you. It's an extremely important part of this course. And there's nothing ashamed to being, there's nothing to be ashamed of if you don't quite get graphs yet. Because it's something we can fix. If you come now, we can fix it. If you come in, yeah, so you could put f of 1 equals 3. Which line? Oh, we'll talk about it. But yeah, it's okay to not quite understand graphs at this point. I'm sorry, I don't quite understand where you put your point and where you're having a question. Do you mean this point right here? Or do you mean another point? I'll be happy to talk to you about it after class. I'm not quite sure I understand your question. Okay. How do we know it needs to head to negative 4? Because negative 4 is what's going on from the left, right? I'm heading to 1 negative, to 1 left, 4. And it's the next thing to the right, correct? So my right points are negative 2 right, and the next one that's defined for me is 1 left. As I move from left to right, I move from negative 2 right to 1 left. And then I jump, and then my next point on the right is 1 right, 5, and 1 right, 5. As I go to the right, the next point's positive infinity, the next x value. Okay. Then name one thing you found from last class memorable, either the lecture or the class. Are there any other questions about the quiz? Yeah. Okay. Well, if there are no more questions about the quiz, I'm going to stop